Hi, this is Stephen Brower from Mountain Valley Community College. This is for CSIT 256, Computer Architecture and Assembly Language. And this is the overview for Stallings Chapter 6, which is on external memory. What I sketched out are going to be 3 videos. One video, and I'll get to in a moment, will be this stuff. Then another video will be on RAID. And then the last video will be on the leftovers. So in that first video, I'm going to focus on a magnetic disk. What are the components of the disk? Things like there are the platters, multiple platters that are on a spindle. There are read-write heads, and actually most of the time there's a read head and a write head. And we'll take a peek at how those function. How the data is laid out onto a magnetic disk. It's written in this track, which is this concentric circle around the disk itself. The disk actually will rotate. The read-write heads, once they move to the right track, they'll remain steady over the track, and then the track will rotate under the read-write head. And so what we'll take a look at is things like the inter-track gap, because we can't have one track write onto the other, so we need a gap between the two of them. The disk is broken down into sectors, and what we'll also see is that there are inter-sector gaps between them. We'll take a look at the constant angular velocity and the multiple zone recording, and it has to do with the constant angular velocity. If we have one speed for the drive, the bits on the outer end are sparser, the further apart than on the inner part. So with multiple zone recording, the speed of the drive is adjusted so that it's running slower for the outside, so we can get more bits per inch on the outer part. And then some final things regarding the magnetic disks. Well, actually, no finals. 2 more. I skipped over one. Oh, because when I do talk about, I'm jumping all over the place. We'll look at the performance, seek time, the time it takes to move the read-write heads to the right track, rotational delay, the average amount of time it takes to rotate the data under the read-write head, the access time, which is the sum of the two, the seek time and the rotational delay, and the transfer time is the time for getting the data. Characteristics of drives, we'll talk about fixed head or movable head, removable disks, non-removable disks, single-sided versus double-sided. In RAID, redundant, RAID, R-A-I-D, redundant array of independent disks, and we'll look at since how they first began with striping and the idea that we could use multiple drives and make it logically look as if it's a larger drive. And so in the video for RAID, I'll show two 500 gig drives, and combined they make a terabyte. And so the idea in the striping is that we can stripe the data over these two 500 gigabyte drives to do on the terabyte. Now, if we lose one of those drives, we've lost all our data, so it's not fault tolerant. RAID 1 will look at mirroring, in which data is written to 2 different drives simultaneously. And so if we have 4 drives, 4 500 gig drives, what will happen is that 2 of the drives are going to be the mirror of the other 2. What we'll do is we're going to jump to then RAID 6, and RAID 6 uses a double parity. This is block level parity, and it's distributed. In other words, there isn't a fixed parity disk that the parity is going to rotate. And for RAID 6, then we need 2 more disks than the capacity that we want, that we need to have. We already looked at flash, but we'll talk about solid state drive. So in a sense, it's like using flash as a drive. We'll talk about that. Optical, many letters for optical, but we'll talk about CDs and DVDs and the similarities and the differences. And I know it seems like it's old-fashioned technology, but magnetic tape still exists. And so I'll just have a comment or two on that. I won't go into as much depth. I think the author spends about 87 pages on magnetic tape. Okay, it's not 87 pages. I'm not going to go into much detail because he gives the tape formats and so on, but just the idea that it is still used in industry in some places. All right, so that's the overview for Stallings Chapter 6.